Hello, this is my 12th lecture, and today we shall discuss about the effect of dielectrics on capacitance of capacitor, and its second case is when dielectric slab partially filled between plates of capacitor. In previous lecture we have discussed about the when dielectric substance completely fills the space between the plates of capacitor, and in that case the capacitance of capacitor is increased by k times of capacitance with vacuum. So on introducing the dielectric substance between the plates of capacitor, capacitance becomes k times of its previous value. And now we shall discuss when a dielectric slab partially filled between plates of capacitor. Means we consider a parallel plate capacitor of plate area A, and this is positively charged, and another plate is with negative charge, and the separation between the plates is small d, and a dielectric slab of dielectric constant K and thickness T is placed between the plates, and the space D minus T, which is empty between the plates of capacitor. So D minus T space is empty space, and a dielectric slab of dielectric constant K and thickness T is placed between the plates. And also we must know that if the geometrical position of the dielectric slab between the plates of capacitor never affects the capacitance of the capacitor, whether the slab is touched with first plate or second plate or never touched with both plates, the capacitance of capacitor or value of capacitance of capacitor remains same. So consider a capacitor of plate area A, separation of plates is D, a dielectric slab of dielectric constant K and thickness T is placed between the plates, and D minus P space is empty. So this is the description. In this, the plate area of each plate of capacitor is A, separation of plates is small d, and a dielectric slab of dielectric constant K and thickness T is placed between the plates. Its geometrical position never affects the capacitance of capacitor, and the D minus T region is empty. Now, electric field electric field of electric field with dielectrics, dielectric slab or in dielectrics. Em is equal to sigma upon epsilon. Epsilon is the permittivity of medium, and we know that sigma is equal to Q by A, and epsilon is equal to K epsilon naught. So Em is equal to Q upon K epsilon naught A. Corresponding potential of Vm is equal to Em into T. Vm is equal to Em into T, and the value will be Qt upon K epsilon naught A. Vm is equal to Qt upon K epsilon naught A. This is the potential of dielectric slab, or potential developed at the dielectric slab. Similarly, for empty space, E0 is equal to sigma upon epsilon naught, and we know that sigma is equal to Q upon A, so Q upon epsilon naught A, and potential in empty space V0 is equal to E0 into D minus T, means Q into D minus T upon epsilon naught A. So this is the potential which is produced at the dielectric slab, and this is the potential produced in empty space, or corresponding potential for empty space. So these are the two potential, and this is for this slab, this region, and this is for D minus T. So total potential between the plates of capacitor V is equal to V0 plus Vn. The value of V0 is Qt D minus T upon epsilon naught A plus Qt upon K epsilon naught A, and the potential is equal to Q upon epsilon naught A can be taken common, and for this reason D minus T plus T upon T. This is the total potential developed between the plates of capacitor. Now, we know that by the definition of capacitance, by the definition of capacitance, C is equal to Q upon V. Q upon epsilon naught A D minus T plus T upon K. Q and Q cancelled out. So the capacitance of capacitor epsilon naught A upon D minus T plus T upon K. This is the capacitance of capacitor, in this case epsilon naught A upon D minus T plus T upon K. We know that the value of K for a dielectric substance is always greater than K. 1. The value of K is always greater than 1. So, T upon K must be less than T. K is greater than 1. K is greater than 1. So, T upon K must be less than T. Now we come to this term. The greater value means T is decreased or subtracted, while smaller value T upon K is added. That means we know that the value of D minus T plus T upon K will be less than D. D minus T plus T upon K will be less than D, and we know that C0 is equal to epsilon naught A upon D. That means this C0 will be smaller than this C. Means on introducing a dielectric slab of smaller thickness, or it partially fills the space between the capacitor, then the capacitance of the capacitor increases. Capacitance of the capacitor increases in this case also. Now again, we know that K metal has value infinite. So T upon K metal is equal to 0. K upon infinite, and this value will be is equal to 0. If a metal plate is introduced between the plates of capacitor instead of dielectric substance, then in that case the value of T upon K will be 0, and C will be is equal to epsilon naught A upon D minus T. And we know that D minus T is explicitly less than D. That means the capacitance will increase. If a metal plate is introduced between the plates of capacitor, then in that case the capacitance of capacitor also increases. If metal plate is introduced between the plates of capacitor, then capacitance will be increased. Capacitance will be increased. So for the case when dielectric substance is completely or partially introduced between the plates of capacitor, the capacitance increases. If instead of dielectric substance a metal slab is introduced, then in that case capacitance of capacitor will also be increased. Now we shall discuss a numerical which is frequently asked in CBSE examination. Capacitor has plate area A, separation of plates B. A dielectric slab of dielectric constant, a dielectric slab of dielectric constant 6 and thickness T is equal to D by 4 is introduced between the plates if capacitance of capacitor is 12 picofarad, then calculate if capacitance of capacitor is 12 picofarad, then calculate the new capacitance after introducing the slab. We know that the capacitance is 12 picofarad and we know that C is equal to epsilon naught A upon D minus T plus T upon K, and this is the value equal to epsilon naught A upon D. If we put the values, epsilon, this is value of C0, this is Cm, we can consider Cm is equal to epsilon naught A upon D minus D by 4 plus D upon 4 into 6. Epsilon naught A upon D can be taken common. 1 minus 1 by 4 plus 1 upon 24. And value of Cm is equal to epsilon naught A upon D into 24 is LCM. Twenty-four is LCM. So 24 minus 6 plus 1. and in this case 24 minus 6 plus 1. So 24 plus 1, 25 minus 6, 19. So 24 upon 19 into 12 picofarad. This is the value of capacitance of capacitor. And we can easily find the values by this number. So this is all about our today's class.